Welcome to the Health Edge, translating the science of self-care. I'm Mark Pettis, and I'm with my friend, colleague, John Bagnulo. John, good morning.
Good morning, Mark. How you doing today?
Doing great. Nice to see you. Here we're getting well into March now, and turning our clocks ahead soon, and spring is in the air. Winter still has a pretty good hold on us here in New England, as you know, and
Yeah.
but it's a promising time of year if you like light and warmer temperatures, and so good to be together.
Yeah, absolutely.
How things with
Absolutely.
you?
They're good. They're good. And like you said, this time of year, you know that despite what it looks outside, that it's just a matter of time before you can get outside with a shorts and t-shirt.
You were just down in Florida recently teaching.
Yeah, I was in the Vero Beach area, which was really a great break. Yeah, I had a program there at a place called Chosen, which is it's a really interesting retreat center where they, offer a lot of different options for groups. So we had an amazing time there, and then I got to spend a couple of weeks with the family. So it was great.
Wonderful.
You got to get down to the Caribbean, right?
Wonderful. Yeah, we recently got back from St. Thomas, beautiful St. Thomas, where
Amazing.
we've had a place down there in years past, which we have since sold, but it's been a frequent destination for us, and it's a beautiful island, and places you revisit, you start to become very familiar with. So it's really like returning to a very familiar place, and it's always great to escape the New England winters. So yeah, we're very grateful in the Pettis family to be able to head south.
Yeah, it's awesome.
And to be with family, and as you know, John, nothing like being with family. And as my kids get older, my kids are in their 30s now. Their family's family, so I feel lucky that my kids live close to home here, and we get to be together. And so it's, as they say, priceless.
Yeah, for sure.
So we have a interesting topic that you had brought to my attention some weeks back, John, looking at the efficacy of a probiotic, in this example, Akkermansia, which is a type of organism that we've talked about before, that is pasteurized. So this is an organism that is pasteurized and then given as I think some would call it a postbiotic supplement, and demonstrating in small numbers of people in a clinical human trial of really interesting and positive effects on metabolic health, blood glucose, insulin, things that we talk about often that are known to be drivers of chronic complex disease. And it brings us, John, into this very broad black box of the gut and the gut ecosystem and probiotics, and then Akkermansia a bit more specifically as kind of a unique player in this ecosystem, and with some uniquely positive effects. And so thank you for forwarding that information. And I look forward to looking at a few papers and kind of an overview of why this is an important topic. And then we'll close with, what does this mean? Is this a supplement worth reaching for those that are either taking a probiotic of a different nature, and it's really kind of a wild west out there when it comes to probiotics.
Yeah.
And so, how would you begin to frame this theme, John, as you looked at it initially?
Yeah, well, a couple things, and I may digress for just a moment as I kind of reflect back on some papers that I looked at. I think one of them was more than 10 years ago, which the researchers, it'll all be connected here in a minute, but the researchers the broader topic of the study was on the food matrix and all the different components in a food that we often, clinicians, consumers, whoever, we often don't appreciate. And so the researchers decided to look at some of the real subtleties of whole foods and what was part of the food matrix. And what they discovered and what was talked about in this paper was that if you take a food, let's say, out of the ground, or you take a food that has a microbial content to it, and what they were really looking at were soil-based organisms that would be on things like the skin of a carrot or on a potato. And the researchers found that when you make soup with carrots, let's say, because again, the broader topic of this whole conversation was the food matrix, and there's a lot of things to foods that we just don't appreciate. They don't appear on the nutrition facts panel, but the carrots and the bacteria that are going to be on the surface of a carrot, even after it's thoroughly washed, but it's going to be made into soup, let's say, that the bacteria on the surface of that carrot, even after it's cooked, the DNA is passed off to other bacteria in the gut, even after it's cooked. And so they found the DNA from these different soil-based organisms. They found it on the, obviously the organisms were on the carrots. They were no longer alive because the carrots had been cooked, but they were able to show how the soil-based organisms were passing on information to gut organisms that were alive when they looked at stool samples of people consuming the soup. So it was a real, for me, when I looked at that paper, it was the first time that I ever appreciated the contributions that bacteria might make to the microbiome, just in terms of their genetic material, right? Because we know there's a lot of swapping of DNA and genetic material. And, I liked how you just referred to it as the black box, so to speak. That's, I think that's a great description, Mark. There's so much that goes on in the microbiome, but we have zero appreciation. We just have no idea, and I think it's just so oversimplified to think like you take a probiotic or, you get this organism and maybe you move the needle a little bit with respect to the populations there. But I just think there's so much more to the current of that river that we don't really appreciate. And I think that, again, coming now to the topic we're on now, which is, what is it on the surface of a bacterial cell wall, let's say, that signals for changes in that gut ecosystem, or maybe in the case of Akkermansia, the gut wall? It really appears to be equally effective at tightening up the gap junctions of the gut wall as having the living Akkermansia there, if you look at some of these studies we're going to talk about. So yeah, it's an amazing component to gut health, the microbiome, and the broader topic of how microbes affect our health. They don't have to be alive, right? They're either passing on information that's going to change the way bacteria maybe, perform certain things in the gut, or how they thrive in our gut, or they're going to contain substances that have direct effects on our physiology. And it doesn't have to be from a live organism, which I think I think that's probably the biggest epiphany here.
Great context there, Ron. And I love you often refer to the food matrix. This is such a fundamental principle around the relationship between food we consume and the health effects, where we become so focused on specific nutrients and vitamins and minerals and macronutrients and supplements, where things are extracted from the matrix and then reintroduced into an animal or a human, and expecting that you're going to see an effect that it can get lost in the context of what it is to receive that in the matrix of the foods that you're eating. And soil-based organisms are a good example. And this other concept that you touch on, John, of the historical thinking that if a probiotic was an alive organism, you weren't likely to see the full effects of whatever that might offer to the gut microbiome and that ecosystem. And these recent papers that we'll look at would suggest that pasteurized forms of the bacteria that really offer a bacteria that's been destroyed, yet some of these surface membrane proteins that are preserved continue to exert very significant biologic and metabolic effects. That's a very different kind of revelation as it relates to this complex interaction. So yeah, I'll bring up a few slides here, John.
Yeah, that sounds great. And you just touched on something I think is really important, which was that pasteurization, which is a much, for everyone's sake here, it's a much milder form of heating, cooking than, let's say, autoclave processing, right? Because I think that's something we'll get to with these studies, that when the Akkermansia, in this case, were autoclaved, they did not have the favorable effect because they were completely destroyed by the high heat used in that, which might be twice what pasteurization is. So that's really, again, it's cool because you think about the food matrix, you think about how foods are normally cooked. When you're making a soup, it's very similar to pasteurization, those temperatures, right? You're going to be in around 200, 212, let's say specifically. No one is cooking food in their kitchen in an autoclave. And if they are, right, it's for very different purposes. So even things like that, those subtleties of how food processing influences the food matrix are incredible.
Great points. And this is just a sampling. We've tried to focus on some studies in recent years. And so one of the questions that I'm often asked, John, and I think when it comes to the microbiome, when it comes to probiotics, there are still so many more questions than there is clarity.
Yeah.
But you begin to see certain microbes that are just getting more attention. They seem to exert broader, more diverse metabolic effects. And Akermansia muciniphila is one of those types. And so again, this was a study from China, Korea, looking at type 2 diabetes and related diseases. This is a review. And again, this includes both animal and a few early human clinical trials. And again, this is just to kind of give people a sense of the themes here, how Akkermansia and metabolic health is now, this was like 2 years ago, leading to some human clinical trials. And animal studies, this graphic is incomplete here. It was cut off. But when you look at, these are liver biopsies, you look at fat in the liver, and Akkermansia, one of its metabolic effects that we'll talk about in more detail is to enhance the burning or the beta oxidation of fat. And that's very desirable for most people. And that in the liver will reflect in a shrinkage or a diminished size of fat in that organ. And that's what this particular study looked at. And then a little more recently, this is a nice clinical overview of benefits and harms of Akkermansia. And I'll pause on this graphic, John, and ask you to comment. But this is a nice, I like this because it's a nice graphic overview of some of the unique attributes of Akkermansia and its effect on the gut and gut barrier function. And just take us through this, John.
Well, the name Akermansia muciniphila says it all. So the mucin layer, philia obviously, attracted to somewhat dependent upon that mucin layer. Akkermansia basically chews into that mucin or mucus-like layer of the intestinal wall. And when it chews into that layer, it actually stimulates the production of a better, a thicker, more protective layer. So in essence, it's like a maintenance worker. It is constantly, just stimulating the production of mucin and keeping that thick protective layer the way it should be, which is going to protect the brush border from a lot of different things, but it's going to help maintain a tighter level of intestinal permeability overall, better integrity for the intestinal wall. And I think that's what we know the most about Akkermansia is, really its preferred food sources. Like you said, some of the more systemic effects that it has in terms of improving insulin sensitivity and increased beta oxidation. But at the gut wall, it's really maintaining that mucin layer. And when Akkermansia disappears and we don't have that presence, then the mucin, the protective mucus layer tends to get thinner. It tends to have less of that protective role. You tend to have higher levels of intestinal permeability. You have to have typically you have higher levels of sensitivity to different substances. I mean, I've heard there are a lot of theories out there about the disappearance of Akkermansia again, I'm not going to be able to cite a study that would fully, validate any of these theories, but I have heard from different people in areas of their specialty, immunology, gastroenterology, that we've had overall this more of a disappearance of Akkermansia, right? And it's why maybe we have the explosion that we have had in the last 2 decades of food allergies, intolerances, things that 30 or 40 years ago were fairly rare are now quite common. Everything from peanut allergy. And again, I'm not going to be able to, fully support or refute any of these because I just don't have that stuff at my fingertips. But certainly the gut microbiome relationship is integral to this conversation. And Akkermansia, as you pointed out, appears to be, maybe one of the top 2 or 3 species of bacteria that maintain the integrity of that frontier, right? That 75% of our immune system is within 1 centimeter, 1.5 centimeters of the gut wall. And if you look at what maintains the gut wall, well, Akkermansia is really front and center for that conversation. So that's the way I really like to summarize its role in terms of gut health, Mark, is just the maintenance of that mucus layer. And we know that when Akkermansia is insulted by things, either environmental exposures or things we eat, its population can be influenced fairly dramatically. And we can maybe talk about that a little later on, but yeah, it's pivotal.
Thank you, John, for that overview. And we've, as I think most of our listeners know, have for many years been exploring in more depth how the gut and this critical barrier, mucin barrier that you refer to, and the integrity of the junctions that tightly align our gastrointestinal cells is really a kind of a fault line in human biology, human health, where disruptions here, what we historically would have called leaky gut, or when I'm with my medical colleagues, I refer to gut barrier trafficking or gut barrier function. That seems more palatable, I guess, than leaky gut. And you begin to see how this systemic inflammation, this alteration in integrity, really does have these downstream magnified effects that we can now connect to obesity and diabetes and cardiovascular disease and depression and degenerative neurologic diseases. So you really do see how, from a systems perspective, how critical all of this really is. And some of these studies now looking at pasteurized Akkermansia, kind of a next generation, right, postbiotic, and postbiotic, as I interpret this language, John, is really, this is a live organism that has been modified, in this case through pasteurization, enough to kill the organism, but as you pointed out, John, not enough to destroy the signaling molecules in the membranes of this organism. And that appears to be an effective modification. And again, the early studies are showing improvements in insulin, gut barrier function. And it interestingly, and for reasons that I can't explain, even appears to have greater efficacy than its live counterpart. And it does, in early studies, appear to be quite safe for adults and kids in managing all of these cardiometabolic risks, from obesity to, as we talked about, fatty liver and visceral fat, certainly management of glucose and insulin. And so it's exciting to perhaps have to move from this Wild West of all kinds of different organisms and colony forming units and to a more specific targeted surface membrane molecular strategy that is probably an easier way for people to access the potential benefits that Akkermansia offers. Is that a fair?
Yeah, that's great, Mark. I mean, absolutely. I think two big things come out of these first papers on this. Number one is the efficacy of those colonizing, those colony forming units. They don't always survive, whether it's stomach acid, whether it's other microbes that they hit first. But for whatever reason, taking some of these really important life forms, but taking them in a live form, they don't always make it, is the best way I can summarize it, right? So you've got really mixed results in terms of using a live form of Akkermansia to change the landscape of the microbiome. For whatever reason, they don't seem to take across all populations and in all different situations. So you got that component to it, lower efficacy of just trying to establish a greater population of Akkermansia. It doesn't always happen. And then you get the whole safety component, which some of it is a little ridiculous, in terms of the regulations that are put on the use of live microbes. There's still some attempt by FDA oversight here to regulate what people are taking in terms of live bacteria. I laugh because there's so much better uses of their resources than this. But that being said, you've got the whole safety component to this. And if you can circumnavigate both of those with a non-live bacteria whose cell wall contains really powerful signals for gut health, whether it's a gut wall. And the other thing that we haven't talked about is this paper, limited population. I think there were 100 adults over the age of 60 who took a heat-treated Akkermansia and had significant gains in muscle mass and strength compared to those who got the control. To me, that's almost mind-bending, meaning that there was something in that heat-treated Akkermansia that increased muscle protein synthesis, recovery benefits from strength training. That's like an entirely different area here than improving metabolic syndrome, which obviously public health wise is that would be goal number one. But if you think about the benefits to muscle mass and potentially all the, everything that comes with that, that's another really intriguing level of this story. But yeah, that's it, man. You got heat treated bacteria that are now producing more favorable results than taking alive forms. It's a game changer.
Mm. Very much so. And just bringing this home with a few other sort of high-level conclusions from the research that currently exists. We've talked about metabolic health, weight and fat loss with pasteurized Akkermansia, which also, and I didn't include this paper, but you will find GLP-1 type effects from Akkermansia in these studies, and it's always important to look at how a pharmacologic intervention, in the example of GLP-1s, very popular currently, those effects can be mimicked through other mechanisms, and GLP-1 is one of the mechanisms whereby Akkermansia exerts these metabolic beneficial effects. And inflammation, of course, is the sort of the passport to aging and reduced health span. You just tend to see improvement, global improvements in this metabolic landscape. And again, this is interesting. I think we'll have a lot more to learn about why it is that pasteurization may have more beneficial effects than an actual live bacteria, which has been the sort of the standard of a probiotic recommendation. And so we've again, just by way of a summary, reducing fat accumulation through this enhancement of fat oxidation and mimicking GLP-1 and other metabolic effects. We know that Akkermansia, John, also is an important producer of butyrate.
Yeah, absolutely.
And butyrate as a metabolic byproduct of fermentation and an important signaling molecule, saturated fat, a short chain saturated fat, is also a very active area of research now in gut health. And so butyrate, very much a byproduct of Akkermansia, and that is very important in its metabolic effects. And I think we're going to see a lot more clinical human trials here, as this appears to be very safe.
Yeah.
Very interesting. And again, I'm always struck, John, by in the human studies that have been done, and how quickly you can begin to see these metabolic changes. We've talked a lot about how quickly you can see changes with reducing carbohydrate intake and ketogenic approaches to metabolic health. When one can leverage the gut and get an amplification of many of these diverse metabolic pathways, they seem to have profound effects in very short time frames.
Yeah, couple weeks, 2 to 3 weeks, you start to see like major changes in that endocrine component, insulin sensitivity. It's really remarkable.
Very much so. And so, John, if somebody, before we conclude, if somebody maybe is debating now whether to take a pasteurized Akkermansia postbiotic, which I would definitely consider and would have no hesitation to recommend. And I would suggest that there are many things one can follow. Often when you're taking a supplement, it's hard to know. I mean, you may or not notice a difference in how you feel. But when it comes to glucose, as you measure that, if you're wearing a continuous glucose monitor, when you're looking at inflammation, when you're looking at insulin levels, many labs now can measure LPS,
Mm-hmm.
lipopolysaccharide, as a
Yeah.
marker of gut permeability. I mean, there are many things that
Right. Yeah.
look at as a measurable way of demonstrating change with this, which is the other really good thing about it, in my view. So, but outside of that, John,
Yeah.
somebody says, geez, Dr. Bagnulo, how can I get maybe more Akkermansia or help the Akkermansia I have thrive in ways that maybe it's not? What are some of the lifestyle or nutrition
Yeah.
strategies that you would recommend to those people?
Well, that's a great question, or maybe a point is that, many of us have at least modest amounts of Akkermansia, and sometimes they just need a little help, right? And what research has shown in terms of associations as well as some cause and effect is that intermittent fasting, a more ketogenic lifestyle, those tend to support higher levels of Akkermansia. In the line of thought here is that if people eat too frequently, you know, eating let's say every 2 hours, right? That constant influx of food stuff and carbohydrates in particular, it suppresses Akkermansia populations. And again, is it because they are going to be outcompeted by other families of bacteria, or is it because it creates an environment where Akkermansia is less likely to work on that mucin layer that we talked about, and it's going to be almost like preoccupied or distracted by food stuff that's coming into the digestive tract? That part's less clear, but we know that really frequent eating tends to be associated with lower levels of Akkermansia, whereas intermittent fasting, a ketogenic diet, less carbohydrates, appears to be associated or supportive of higher levels of Akkermansia. So that would be one observation that's really consistent across research on this bacteria. The other is it's very sensitive to Akkermansia is very sensitive to certain chemicals and artificial sweeteners in particular. Studies have looked at sucralose. Studies have looked at, NutraSweet, aspartame, and very, very minute amounts of those artificial sweeteners tend to have very detrimental effects on Akkermansia populations. So artificial sweeteners really suppress it. Intermittent fasting tends to really encourage the growth of Akkermansia. We know that polyphenols, like the polyphenols that would be found, cranberries are one that I, like off the top of my head, I know cranberries contain a mix of polyphenols that appear to be incredibly conducive to feeding Akkermansia. Pectin does as well. Pectin being found in, certain fruits like citrus fruits and in the peels of citrus fruits and in unripe apples. They have much, much more pectin than, let's say, a ripe apple. But and you can buy obviously pectin powder. People use it for canning, and you wouldn't need to get modified citrus pectin to feed Akkermansia. You could use pectin powder that would be fine for like making jam at home, and which people used for a long time when they made their own fruit preserves. So there's a lot of different polyphenols that feed Akkermansia. Pectin is the type of fiber that's most effective at feeding it. And you want to give yourself a break from eating, whether you need a 13-hour or a 14-hour. I don't know that. I just know that, not eating all the time is generally associated with higher levels of Akkermansia. Those are some of the big kind of high-level observations. And the last one is people who are more aerobically active. And again, the thought on this, it has something to do with blood flow to the gut. But people who are kind of in a more higher intensity aerobic activity level, they tend to also have higher levels of Akkermansia. So, and of course, the question becomes, is Akkermansia, a byproduct of some of these lifestyle components, or is it also making those lifestyle components a little easier for people to even adopt? That's, because we know there's a back and forth, right? Gut microbes have a lot of influence on our mind, on our aerobic capacity, as you and I have talked about. It's not a one-way street. It's probably a two-way street to some extent, right? So I think it's a really fascinating topic, though, because all of those different components of lifestyle that you and I have talked about, Akkermansia seems to be really intertwined with those intricately.
Brilliant way to close this discussion, John. Thank you for that.
Yeah, it's awesome.
And this recording will be on our website, thehealthedgepodcast.com. We'll put a few of the papers that we referenced here that are open source on that site as well. And John's Substack material is just awesome. His last one,
Thanks.
And this is just brilliant news to use. And
thank you, Mark. Appreciate that.
Of course,
Thanks
please
so
check out John's Substack. You'll be very glad that you did. And until next week, John, great reviewing this topic. Yeah,
it was fun. Thank you, Mark.
Relevant for next week. And until then, you be well, stay well, my friend.
Hey, you as well, buddy. Take care.